Hello viewers and welcome to the e-learning class. So today we'll be looking at velocity time graphs. So we have 10 graphs here which we'll be analyzing to know what they mean, the velocity time graphs. So we start with the first graph. So the first thing to note here is that for every graph we must understand what the slope represents. So we know slope as slope represents change in velocity over change in time, which is acceleration. Slope is acceleration because it is a change in velocity divided by change in time, which is acceleration. So let's look at the first slope here. So the slope is 0. And when the slope is 0, it means acceleration is 0. Therefore, the body is moving with uniform velocity. The body is moving with uniform velocity because acceleration is 0. Let's look at this other one here. The acceleration is constant. In other words, slope is the same everywhere. That means the body is moving with uniform acceleration. We have said uniform acceleration means uniform slope. Acceleration is increasing here. So this one is, slope is increasing. So this one is increasing. Acceleration. The body is moving with increasing acceleration. We have decreasing acceleration here. The body is moving with decreasing acceleration. Decreasing acceleration. We go to this other one, slope. So if you look at the slope here, it is constant, meaning acceleration is a constant, but now it is negative. That means the body is decelerating. So this is the body, this is the decelerating body. The body is decelerating because if you look at the final velocity, it is 0. And the slope is a constant, meaning acceleration is constant but negative. This is a negative slope. Negative slope means negative acceleration, which is deceleration. Then here we have two parts, the first part and the second part. So for the first part here we have deceleration. So this is a deceleration. We have deceleration here, or we can say this is a decelerating body. That is from here up to here. Then from here up to here, if you look at the velocity, it is increasing on the negative side. So that means this one is, the body is accelerating. The body is accelerating on the opposite direction. So the body is accelerating, but this time round on the negative side. Remember, on the opposite direction, because you realize that velocity is towards the negative, that means it is accelerating, but now towards the opposite direction. In other words, past the origin. We have the two parts again here. So this part here is, the body is accelerating. So this is accelerating body. Accelerating body. Then this part here is decelerating body. The reason why we are saying on the other part it is decelerating is because the slope is constant, but if you look at the final velocity, it is 0, meaning the body is decelerating. By the way, it's important to note, for this graph here, for this particular graph here, this one represents the motion of a body which is thrown upwards. When you throw a body upwards, you realize that this slope here, because the body decelerates upward and then it accelerates downwards. So when you throw a body up, it decelerates upward, and then as it goes down, it accelerates. But now in the opposite direction, such that you realize the initial velocity is the same as the final velocity, only that one is negative because of the direction. So we go to the next one here. That's the heavy one. So if you look at this slope here, the slope is decreasing, meaning this one is decreasing. The slope is decreasing, meaning this one is decreasing acceleration. Somebody would wonder, why is it decreasing acceleration? We have seen the slope represents acceleration, so as long as the slope is decreasing, then it means acceleration is decreasing. Again, it's important to note that the body is accelerating. If you look at the velocity here and the velocity here, the velocity is increasing, only that the acceleration is decreasing. Then we have this part here. This part here, so the body is moving with increasing acceleration. That is increasing acceleration. That is increasing acceleration. No, sorry. This one is increasing deceleration, increasing deceleration. That is increasing deceleration. The reason why we are saying it is increasing deceleration, you realize that the slope is negative. If you pick any tangent here, the slope is negative, and when the slope is negative, it means acceleration is negative, because slope is acceleration. So acceleration is negative, that means the slope is negative. So negative acceleration is called deceleration. But if you look at the slope, it is increasing. That's why we are saying it is increasing deceleration. And if you look at the final velocity here, it is 0. The final velocity here is 0. Let's look at the next one there. The next one there. So we have this body here. The velocity is decreasing up to 0. That means the slope is, first of all, the slope is decreasing. That means decreasing. The slope is decreasing, so that means decreasing deceleration. That is decreasing deceleration. The reason why we are saying it is deceleration is because the slope of this line is negative. The slope of this curve is negative. Remember, as long as the left hand is above the right hand, slope is always negative, and when the slope is negative, then it means acceleration is negative, and the negative acceleration is called deceleration. So we are saying now that is a decreasing deceleration, because slope is decreasing, so it's decreasing deceleration, and the final velocity is 0. The final velocity is 0. That means the body is decelerating. Then finally we have this. So first of all, the slope is decreasing. That means we have decreasing deceleration. 1 minute. These are decreasing deceleration. Decreasing deceleration is there. Opposite direction. That is a decreasing deceleration in the opposite direction, decreasing deceleration in the opposite direction, because if you look at the final velocity is 0, the final velocity is 0, that means the deceleration is decreasing, but now in the opposite direction. That's why the final velocity here is 0, but you also realize that the slope is decreasing, meaning the acceleration is decreasing. The deceleration is decreasing. So that marks the end of velocity time graphs. In case you have any queries, you can send your questions. So we stop at that point. See you next time.